Good morning. I am Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. Rajalakshmi College of Arts and Science. In today's lecture, we are going to discuss about modes of operation. So we already discussed the modes of operation in earlier session. So with that continuation, I will discuss today. So the next topic in modes of operation is message padding. So message padding where we are using it means so if we want to add one more block but it doesn't have a more values or data with it means on that time we'll use this message padding. So what it does means it adds one more bit at the end of the block we already have. So by adding one more bit with the same block, what it those means it avoids the need for extra block. So if we need any other extra block means by using this message padding, we'll avoid that one. Ciphertext stealing. So it uses to make ciphertext length same as a plain text length. It requires more than one block of plain text. Okay. So text stealing. So here what we are doing means we are converting ciphertext into plain text. So the length of plain text and the ciphertext is same. Okay. So for conversion, the plain text it needs a more number of blocks to convert ciphertext into plain text. So the main advantage of it is a ciphertext block depends on all blocks before what it has, and any changes we are doing for a particular block means it affects all the ciphertext blocks, and it needs initialization vectors. So we have to know sender and receiver. If send is clear, attacker can change bit of first block by changing corresponding bits of initialization vector. So hence it might be a fixed value. So we have to specify a fixed value for initialization vector, or we have to send encrypted ECV mode before rest of messages, or we have to use or we have to check every message already we have shared. Stream modes of operation. So block modes encrypt entire block. May it need to operate on smaller units like real-time data. So if we are using a real-time data means in that place we'll use a stream mode of operations. So convert block cipher into stream cipher. So for that conversion we are using three methods. One is cipher feedback, output feedback, third one is counter. So we'll see one by one. Cipher feedback. So here messages treated as a stream of bits. We can add the output of the block cipher. So the result of feedback for the next stage is taken for the next block. Okay. So if we are executing the first block means that block result is taken for the next block execution. If it doesn't send any feedback means we didn't execute our cipher feedback section. So this is the pictorial representation how the cipher feedback is working. So here we have initialization vector. With that we are adding a key. So we are encrypting a particular thing. Okay. So for the encryption we have to select S bits stream of bits. So what kind of data will be encrypted, so that we have to specify. After that we have to add S bit again with the plain text. Okay, so at last we'll get a ciphertext. So like this we are converting, we are doing the encryption. So the opposite way of encryption is decryption. So in that way we are converting ciphertext into plain text. So the main advantages and limitations of cyber feedback is it is most common stream mode. So it is appropriate when data arrives in bits and bytes. The limitation is need to stall while do block encryption after every S bit. Note that the block cipher is used in encryption mode at both ends, errors propagating for several blocks after the error. So from this, you'll understand about what is the stream modes of operation. So in this stream modes of operation, we have discussed about cipher feedback. So one particular block feedback is taken for the next block of informations to encrypt a particular data. Thank you. Let's see the next topic in the next session.